Welcome everyone. It's great to be back here. Everybody, you can see my screen, right, Caitlin? All right, sounds good. So we'll go ahead and get into um, discussion tonight. But to start out, I just want to go over just kind of overview. But first, I want to do a quick little poll. So if you pull out your phone and if you open a text message and send to the number 37607 up here at the top. And then in the message, body of the message, if you do Adam Wild 676 and send that, then you'll be registered for the poll everywhere. And then you can go ahead and answer this question: is making maple syrup important to you? So how important is it, in your opinion, to have quality maple syrup? And so in the response message, you can do 1, 2, 3, 4, or 5. Oops. All right. So 1 is no, all maple syrup tastes fine. It's not that important. 3 is sort of, it comes out okay most of the time. Sorry, these aren't showing up all the way. Worked okay beforehand, and then 5 is yes, I want to have the best product available for my consumers. So if you put that in, just what your thought is on how important it is to have maple syrup. So 1 through 5, 1 being not that important, 5 being important. You can also scan the QR code for that. So just tonight I just want to cover kind of some overview of making quality syrup, and some of this might be a little bit of repetition for some of you folks as we go through, but hopefully it'll be some good reminders, and hopefully we'll have some new information that we'll cover and you'll learn as well. So thinking about kind of first where flavor of maple syrup comes from, and then what are some of the things that we do in the processing aspects to influence the quality of that finished product that we get, and then finishing with kind of some things on flavor and off flavors that we get within maple syrup. And I tried. Apologize that the poll is not working. So I guess we'll go ahead and move forward without that. I apologize for that. So let's first think about understanding kind of the chemistry of maple sap, because that really helps understand where our flavor comes from, because what's the chemistry of the sap is really going to control kind of what's happening in our evaporator for the finished flavor of maple syrup that we're going to get. And so, as I think we're all aware that in maple sap that it's primarily water, right? It's 98% water, typically, depending on your sugar level. And then the sucrose is, on average, say around 2%, maybe higher, maybe lower. But within that sugar, and it's not just sugars and waters, but there's minerals, lots of different minerals, mostly calcium, potassium, but there's also amino acids that are in there as well that we'll talk about, how that impacts flavor a little bit. There's organic acid, there's polyphenols, which are like antioxidants, which are great for having a boost, or helpful for having that maple syrup, kind of health benefits that are within there as well. But most of this is water. But we are reducing that down, and we're concentrating that maple syrup up to 66 to 68.9% sugar, and all those minerals, amino acids, and everything else are going to be concentrated in higher levels also, and are going to be impacting the flavor of that maple syrup. So we think about kind of where the flavor of maple syrup, the quality of maple syrup, I kind of like to split it into 3 different components that kind of impact the overall flavor or taste of maple syrup. One is biological, number 2 is the microbial aspects, and the third one is what we as maple producers are actually doing in that processing aspect that can impact that flavor of our finished maple syrup. And so to delve into these a little bit, if we look at first the biological, that it's important to remember that trees are living organisms. And so there's lots of things that are happening within our trees as they're living organisms. There's different things that happen each year. And so that's going to impact your flavor from year to year. but also there's things that are happening throughout the season. So this was a study looking at some different compounds within maple sap and syrup and how that impacts flavor, and really trying to look at kind of off flavors at the end of the season, especially buddy syrup. So it's this system biology approach to kind of explore these impacts on maple trees, and looking at that breaking out of dormancy when we typically associate with buddy syrup. And we'll talk about buddy syrup a little bit at the end, but interestingly enough, what we typically call buddy maple syrup, which if you're familiar with the Quebec standards for off-flavor maple syrups, that's our V5, that we associate it with the buds breaking open, and that's typically when we get that flavor, but we haven't actually shown that for sure that it's the opening of the buds that actually trigger the off flavors within the maple syrup by that time that we get in our buddy syrup. And maybe it's just a correlation of happening at the same time. But as we can see, there's a couple different compounds within maple sap as we progress throughout the season, where the top one, looking at the sulfur within sap, that increases as we get later into the season. The x-axis here is looking at the cumulative temperature away from the bud break, so how close. So larger numbers further away from bud break earlier in the season, the smaller numbers are getting close to bud break. So we can see sulfur really increase as we get closer to bud break as we progress throughout the season. Also, ammonium is increasing as well. And we see this vary with phosphorus and other minerals and things that are within our maple sap. And so there's a lot of variation that can happen. And just kind of on another biological note as well, in that there was a study a few years ago that looked at the carbon isotopes within maple syrup to try to date the sugars that are within our maple syrup of when they were actually made. Because a lot of times we think that, and it's a natural assumption, that the sugars that we're collecting this maple season right now were produced last summer during the growing season when the trees were photosynthesizing. But by looking at these isotopes within the carbon isotopes in maple syrup and dating those to when those were actually produced by the tree through photosynthesis, that found that on average, that's oftentimes like 3 to 5 years. And so there's really what's happening in the last 5 years can be impacting the maple syrup flavor that you're going to be getting this maple season or this coming maple season. So that's biological aspect plays a big role. There's a microbial aspect as well. And so there's a lot going on with microbial. And so if we kind of dig into this a little bit, we try to look at the sugar composition within sap, which isn't the microbial part, but we'll get in where the microbials tie in here. But as we get maple sap from a tree, a sterile maple sap, the sugar profile is all sucrose. So coming that raw sap straight from the tree is all sucrose. But some of that sucrose, as it's sitting in your collection buckets or tubing or collection tanks, that some of that sucrose will change into invert sugars by a microbial fermentation. And invert sugars are really responsible for a lot of the darkening and flavor development as we process that sap down into maple syrup. And so we'll show this and we'll get into this a little more, but sucrose is a more complex sugar. And so how we get that maple flavor, because remember, maple sap, as we all know, is clear liquid, much like water. Doesn't look like maple syrup until we cook it down. So I'll come back into that microbial fermentation and how that plays into it, but as the flavor, but to think of, again, where is this flavor coming from as we delve into that a little bit more of the actual flavor of maple syrup. There's a few different areas that we can look at as well. And so one is terroir, which is typically used in the wine industry. And that's referring to kind of that connection between taste and place, of that the environment, the climate, the soils of where that plant is growing. So in this case, where our maple trees are growing, or sugar bush, the soils and the minerals in the soils that are growing in, the climate that it has is going to have some impact on the flavor of that maple syrup. And it's more subtle in maple industry. It's not like wine. I mean, there's still a lot of processing, and how we handle that sap is going to have more of a control over it. But then when we look at the kind of more into the chemical reactions, there's two different ones. There's a Maillard browning and a caramelization. We're going to delve into these a little bit more. And so going back to thinking about that microbial fermentation of sucrose, and I mentioned that sucrose, remember raw sugar from the tree is all sucrose, but it can ferment through different microbes feeding on it, mostly yeast, could be some bacteria as well, but mostly yeast or other microbes that are feeding on it. And so when sucrose ferments, it actually breaks down into one glucose molecule and one fructose molecule. So that goes into those simple sugars, which we call our invert sugars. The glucose and the fructose are invert sugars. And this isn't heavy fermentation. This isn't like making alcohol, but just a tiny bit of fermentation. And why this is important to discuss is that when we look at the caramelization temperature of maple syrup, which is helping to give flavor into our maple syrup, and that sucrose caramelizes in the higher 300-degree Fahrenheit range or 185 degrees Celsius. So that's a pretty high temperature. And so that's well above what our maple syrup is actually finishing temperature point. Well, there is some chance if you're any of those sugars that maybe are on the bottom of your pan that get direct fire, kind of high heat at the bottom of the pans, any sugars down there may get a little caramelization. But if you had all sucrose in your sap, you're really probably not going to get a lot of caramelization, a lot of flavor. You're going to make a lot of light syrup if your sap was all 100% sucrose. Glucose is a little bit lower temperature, but still pretty high. Whereas fructose caramelizes at 219 degrees Fahrenheit or 104 Celsius, which is right where we're finishing, the finishing temperature for our maple syrup. So the more fructose we have in our maple sap, the darker syrup we're going to make and the stronger flavored maple syrup that we're going to make, because more caramelization is going to be happening within that sap as it's boiling down into maple syrup. And so when are we going to get more of this microbial fermentation, which means more fructose and glucose, especially focusing on the fructose? That's going to happen when our temperatures are warmer, our sap's warmer, the microbial reactions are going to be even higher for that. And so that's why typically later in the season, we're making those darker syrups when the weather is a little bit warmer. There's some other factors in there as well, but that's a big part of it. So that caramelization, that browning of those sugars, it's a heat and sugar chemical reaction that's happening. We need that high heat for it. And it's happening mostly in our reducing sugars, mostly that fructose. The other piece, as I mentioned, that's giving a lot of flavor. The caramelization's easiest to think about because most people are familiar, like, with caramelization and know that if you cook sugars, they brown, and it's that caramelization process. But another one is the Maillard reaction, and this is what gives like the browning on bread or steaks or cookies or things like that. That browning, which is, it's also a chemical reaction that's happening with heat with especially our reducing sugars, but most prevalent. The difference between this, though, is that the Maillard reaction also requires amino acids to interact with that as well to help give that distinct flavor for the Maillard reaction that's happening to help give our flavor. So this is actually playing a really big role into the flavor of maple syrup. And if we look at, going back to this one study, if we look at actually amino acids, we find that as we progress later in the season, the amino acids are actually increasing later in the season. And the larger triangles are referring that to higher chance of forming the buddy syrup, the class 5 syrup. And so later in the season, more likely to get more amino acids. And so if you have more amino acids, you're more likely to get more of that Maillard reaction. So later in the season when we're making dark syrup right at the end of the season, that's most likely because of all the amino acids that are there, along with the more fructose that allows more caramelization and more of a Maillard reaction to occur. Um, so we think about kind of controlling those invert sugars again, just so if your sap is warm, how long it's stored, maybe if you're passing it through any filters that could help filter stuff out and reduce some of that fermentation, but could also inoculate it as well. Or if you're splashing a lot, giving it lots of oxygen, which I'll talk about in a minute. And then if you're not cleaning well, you'll have more of a microbial population build up that can cause more fermentation. And so this is kind of that human activity side of things. Remember, we have biological, the microbial, which is that microbial fermentation of the sucrose down into fructose and glucose, and then this human side of how do we handle the sap, how long does it sit around, how quickly do we boil it, and then any things we do that filters that can add off flavors and things like that that we'll get into a little bit later. So important thing about storing your sap, remember, sap can spoil quite quickly, especially in warmer weather. And so the longer it sits around, that can be the worst case. Sitting around a little bit and getting a little bit of fermentation is okay, but we don't want to go too long, obviously. And so think about maple sap as like milk or something like that, where you wouldn't want to leave milk sitting out for 3 days in 50-degree weather. You wouldn't want to do that with sap either. And so picture on the left here is some maple sap. This was in one of my research canisters that I didn't get emptied at the end of the season for a little while, and came out a couple weeks later, and this had turned into this like big gelatinous blob of goo. You see it's not soaking into the nice dry leaves at all or ground. It's just kind of floating like this big mass because that had gone what we consider ropey, as being kind of stringy. I mean, you can put your finger under that and kind of pull it up a little bit. It's slimy. So I realize that a lot of people don't take pictures of nasty looking sap, so whenever I see some, I like to take some pictures of how it can get late in the season. Here's some being circulated in the middle here, really foamy. So we got a lot of yeast forming in there. On the left has a lot of yeast formation on the top of the tank. On the right, this was some late season stuff that was not being boiled. That was when pulling taps and was way too warm, was really fermented, and this was actually like a thick layer across the top that you could like rest a pencil on probably without it sinking. So oxygen is actually helpful if we want to try to increase some of that microbial activity. So there's two different types of fermentation. We can have anaerobic and aerobic fermentation. Anaerobic fermentation is without oxygen, and that is not a type of fermentation that we want within our maple sap. The type of microbes that have anaerobic fermentation give a lot of off flavors, especially like sulfur off flavors. So I like to think about swamps. Our swamp water is very oxygen depleted. So those are anaerobic, and you think about swamp water is kind of sulfury, kind of nasty, rotten egg smell. And so if you have maple sap that's depleted in oxygen, and there's not going to be a lot of great aerobic microbial activity that we want to have. And so that can impact the syrup flavor. And so one of my colleagues at Cornell a few years ago did a study of taking a sample of maple sap, splitting it into two different tanks, and storing one as the control, and then taking another one where they was aerating it and adding oxygen into it. And this was some late season sap. And this is so stored the same amount of time, one had air added into it, and then boiled together just on a hot pot here. So not an evaporator in a large scale, but just showing the difference is on the left here is that control without any of the oxygen added into it. On the right is when oxygen was added, where it increased the microbial fermentation activity. You can see how much darker that syrup is there, gave it stronger, more flavor, and helps to even it can, if you have some really subtle off flavors from maybe some late season where the sap's starting to get a little bit sour or something like that, you can sometimes cover up some of those off flavors slightly by getting that syrup to be darker, stronger flavor to kind of mask over it. Um, so ways to change or impacts on dissolved oxygen within your maple sap. So high vacuum levels actually decrease the dissolved oxygen within our sap. But any agitation from your releasers or dumping sap from tank to tank or dumping buckets of sap into a tank or anything like that, or just circulating it, it's going to add oxygen, any splashing you can do. But dissolved oxygen levels will fall as sap sits undisturbed. Any microbial activity are going to deplete the oxygen that's in there. Late season sap loses that oxygen more quickly because of more microbial activity that are feeding on the oxygen that's within that sap. All right, so that's kind of our flavor, where our flavor is coming from. So I think it's important to kind of have that in mind as we approach the rest of these kind of topics. So I want to get into now thinking about different factors to consider, some of the human side of things to consider when we're making quality syrup. And so the First of all, I want to talk about density. So density, that's the percentage of sugar that you have within your maple syrup. So that finished maple syrup density. So we'll try this poll thing one more time. I had a couple more coming up. If this doesn't work in this one, we'll skip over them. But so if you want to try to do the same thing as before, if you already joined before and you got a response, then you shouldn't have to type in the Adam Wild 676. You should just be able to type in, and this is going to be free form. It doesn't have to be a number or anything. Type in the density, which should be between a range of 66.0 or 68.9. So what do you think is your preferred density where you like to finish maple syrup that you think is the best mouthfeel? So we'll try that and see if it works. So density is probably the most important thing. If we don't get that density correct, it's kind of impossible to have a good quality maple syrup. So if we're too thin, if we're below the density, so below 66.0, not only is that have a really runny kind of syrup, that a consumer is not going to like because it's going to be more watery, but it also has a higher chance of any mold forming, and also you can have fermentation as well. And so I've seen plastic bottles of maple syrup that are all kind of ballooned out because they weren't cooked to a high enough density, and the fermentation was in the carbon dioxide release was expanding those bottles when we're about to blow open. So we don't want to be too thin. And then if we go above that 68.9%, then we have a high chance of crystallization forming, which consumers aren't going to appreciate as much. They're losing out kind of on product, or they try to like melt those down or get them out of the bottom of a bottle, and it's hard. So it's really important to be within that range. Let me see if these responses, nah, sorry. I think it's might be because I shrunk them down a little. Like it said, the poll says I need to open it. Thanks for that, Megan. Let me. Yeah, it should be open. So I had it open before, but anyways, sorry about that. We'll move on. Anyways. So how do we actually determine the density of our maple syrup? So there's 3 different methods that we can actually use. The most basic is to use a thermometer. This is effective. It works well if you do it correctly. And so to use the thermometer, if we want to be 66% sugar, is 7.1 degrees Fahrenheit above the boiling point of water, or 4 degrees Celsius above our boiling point of water. And why I say the boiling point of water is that there's a large variation that can happen within thermometers, and also your elevation and the atmospheric pressure at that given day. And so not all thermometers are accurate. So just because if we figure that we're close to sea level and maple syrup, we want to be 7.1 degrees Fahrenheit above boiling point of water at 212 degrees at sea level, or say 100 degrees Celsius. Then we'll add that 7.1 Fahrenheit to 212, so 219, and we put our thermometer in. That doesn't mean that that is to the correct density. You still could be thin because thermometers are not always perfectly accurate. They can vary by half a degree or more, and that can make a big difference in your boiling or your finishing temperature, which can really impact that final density of your maple syrup. And doesn't matter how expensive a thermometer you bought, they can all vary a little bit. And I don't recommend taking 3 thermometers and using the average of all of them. The best is to boil a little bit of water, put your thermometer in, and measure at what temperature water is boiling, and then add 7 degrees Fahrenheit onto that, or 4 degrees Celsius onto your boiling point. So it's good to do this every day to boil. It doesn't take really long to just throw a little bit on a stove and test at what point water is boiling, and add that onto it. So that's the best way if you're a small batch maple producer. Another option is a refractometer. Not the best option. So either this analog style on the left here that you put a drop onto, close the lid, and look through what the density, or a digital one that has a drop they put in this prism, close the lid, and hit the go button. It gives you a percentage of sugar reading or Brix reading within that syrup. It doesn't take much syrup to do this. You want to make sure that your refractometer is not just a sap refractometer. Like the sap refractometers are usually like 0 to 20 or 0 to 30. You want to make sure it has a scale for syrup, which are usually like a 40 to 80 roughly. So that's important. So you need to have a separate one. Refractometers are great for measuring sugars and sap, but they're also not really stable with hot syrup that is right off your evaporator. If you're canning syrup, that's a little bit better. That's okay, but hot syrup, they're not really stable. And also, you're only using a few drops of maple syrup, and if it's really hot off your canner, as it goes onto your cold prism, it's gonna fluctuate, and it's going to be hard to give an accurate reading. But also that hot syrup could have a tiny bit of moisture evaporate as it's still really hot going into your onto that refractometer, and that little bit of moisture evaporates, is going to change the density. So I don't really recommend these for finished maple syrup. They're great for room temperature syrup if you want to know what's your bottled syrup, or if you're bottling syrup, or you're opening a barrel and you want to do test that to make sure it's the correct density before you bottle it. It's great for that. It doesn't take much syrup, and it's pretty quick. But I don't recommend it for hot syrup. What's the best method for hot syrup usually is the hydrometer. And it works great, but it does need a little bit more syrup to do this. So if you are a small producer, you need to be able to fill the whole cup, and that can be hard if you're not making a lot of syrup. But the really important thing is that it needs to be calibrated to the temperature of the syrup. So if you're coming straight off your evaporator right away, you can be okay, but it's really important if there's any drop in temperature to be able to calibrate that or compensate with a compensation chart for it. And so these are usually set up, show you a picture here. The hydrometer, this glass tube with a little weight at the bottom. These are set up that this weight is specific for maple syrup, that as your syrup is, if it's not that dense, the weight of the glass tube is going to pull down and even sink all the way to the bottom. If it's the correct density, it's going to float within here. If it's really dense, it'll float even higher. And so we're looking for typically these red lines. They're calibrated typically for 66.9 degrees Brix, or sometimes they'll be calibrated for 66.0 degrees Brix. It depends on where you get your hydrometer. I don't know In Nova Scotia, you might have a lot more 66.0 if anybody wants to throw in the chat or Q&A of what their hydrometer is. In the States, a lot of times we get more 66.9 because in actually the state of Vermont, their minimum standard is not 66.0 for the bottom density of maple syrup, at 66.9 for the minimum. So a lot of the hydrometers are calibrated so that at 60 degrees Fahrenheit, it'll be 66.9 when it's at that temperature. But the temperature of your syrup is going to change the density of that syrup. And so that hydrometer will move up and down depending on the temperature of that syrup, because it's going to change the kind of density or viscosity of that syrup. There's typically two lines on them. One on this bottom line would be the 66.9 degrees or 66.0, depending on how it's calibrated for. It's important to read the little paper inside the tube. And at 60 degrees, and then there's usually so that's the cold test, and then there's usually a hot test at 209 degrees Fahrenheit, which on the hydrometer will actually read 59 degrees Brix, or percentage of sugar, but at 209 degrees Fahrenheit, that's actually 66.9% sugar, 66.9 degrees Brix, because of the calibration that happens. So if we look at this chart on the right-hand side, we can see this range of sugars that can happen depending on different temperatures. So the acceptance range, this is the bottom and the top, and this is based on 66.9 to 68.9, so it doesn't go down to 66.0. So in Nova Scotia, we could be a little bit lower than some of these numbers. So we'll notice here that 60 degrees, this is Fahrenheit, will be 66.90. And then we know our max is 68.9. So if your syrup is 60 degrees, even perfectly, your hydrometer, you need your syrup to be within there. But if your syrup is, say, 185 degrees, you're canning that, you're heating it up to bottle, then that hydrometer should read between 60.5 to 62.5 to actually be 66.9 to 68.9. Hopefully that makes sense for everybody. If not, or feel free to throw any questions in the Q&A, and we can try to answer that if that's not making sense. I'm going to show a couple examples. There are also other charts out there. This one is more of a Brix adjustment. So depending on, you measure the temperature of your syrup. Let's say it's 202 degrees, then you're going to add 7.5 to what the hydrometer is actually reading. So that might be a little bit easier to understand if you want to know exactly. This other chart just showing you the range that you should be in. Are you in there? It's more of a yes, no, is that good or not? Where this one is actually looking more of that, getting a little bit closer. A hydrometer is not really meant for getting into like quarter degrees Brix. It's really more half to 1 degree intervals. And so you can add that onto it. And again, if we're off just 1 degree Fahrenheit error, that can happen in like this hydrometer, but similar in your thermometer as well, that it can fluctuate that Brix level, that you can be either 60, maybe down to 63.4, so really thin syrup, or up to 69.3, the high, which is going to give you these sugar crystals forming in the bottom of your jug. All right, so let's look at some example of what's the density of this syrup. So if we look at this hydrometer floating in this cup of syrup, so there's 70 degrees Brix. So we see there's a line for 70, and if we look at it, I put this chart on the left-hand side here so you can see which way that's going. So it's the large numbers are getting larger as it goes down. So here's 71 degrees Brix, or percentage of sugar. And so we're probably not quite to 72. We're somewhere around probably 71 and a half, 71 and 3/4 in that. But what's important is to know what's the actual temperature of the syrup. And so this picture is saying that it's 200 degrees Fahrenheit. So what we need to do is go back and look at our chart here that 202, we don't have a 200 perfectly, we have a 195. So if we look at 200, we know we can lower this or go up just a little bit, that we should be between 59.6 to 61.60. So is this maple syrup in the correct density range? And what is the actual density of this maple syrup? And so looking at this, we know we should be, say, somewhere around 60.0 to high 61 to be at 200 degrees Fahrenheit. And we're at 71, so we're way out of it. So this syrup is way too dense in for this. So this is not the correct density. We need to thin this down. Here's this chart. If we want to look at 202, so we need to add, you should be adding 7.5 to the actual reading that you're getting. So if this was 71 and we add 7 or 7.25, so we're high 70% in the percentage of sugar. So this is definitely way too dense. Another example, what's the density of this one? And so for reading, this line is right at 65. If we look at either of our charts here at 125 degrees, we should be between 63.65 and 65.65. Or we can go over to 120. We don't have 125, but we can say we need to add 3.25 to that. So 65 plus 3.25 would be 68.25 degrees Brix. And so that one would be, that's right in, that's on the high end. As we see here, we're on the higher end of the chart, but we're within range. And so that's great. That one would be illegal. Looking at the Q&A, there's one saying from Jade that our syrup at 219 degrees Fahrenheit is much too thin when tested with a hydrometer. We have to continue slow boil to try to keep it from going over 119 until it thickens. I mean, I would think you want to potentially go over 219 if it's still not finished. I would calibrate your thermometer to see 219 may not be your actual finishing point. So, or 212 may not be where water is boiling with your thermometer. Maybe it's more like 213. And so maybe you do need to go to like 220 to be more of a dense maple syrup. So I would test your thermometer to see how accurate that would be. But great observation. And I'm glad you're using a couple different things. It's nice to have a hydrometer and a thermometer to kind of look at both. It's also important to either replace your thermometer or have them tested every so often. There are places that will sometimes test them for you, or you can buy certified ones. There's ones that aren't certified sometimes, and sometimes that little paper inside there can slip down inside of the hydrometers occasionally. So it's important to make sure that your hydrometer is actually correct. I know Center Acer in Quebec sells a 60, I think it's a 66.0% Brix kind of standard solution that you can purchase to actually test your hydrometer to make sure that it is floating, and you can do the temperature and check that make sure it's accurate, because they can change a little bit. Another thing to also check is on your hydrometers that you can get like niter, just like in the bottom of our pans, we can get niter sugar sand that can build up onto the hydrometer, and just a little tiny amount of that sugar sand is going to change the weight of that hydrometer, which is going to throw it off as well. So if your hydrometer is 10, 20 years old, it's probably good to replace that or get it cleaned at least. Question from Mitch, thoughts on a Murphy cup. Murphy cup, some people love them. Me, myself, I'm not a big fan of them, but some people really like them. So if you like it, use it. A Murphy cup, I didn't put in my slide here, but just a quick explanation for those who are interested. A Murphy cup has so it's your hydrometer cup, a stainless steel hydrometer cup, and it has a thermometer on the front of it, and you can buy hydrometer cups that have just a normal thermometer, which are kind of nice because that tells you the temperature of the syrup in that hydrometer cup, and so that you can look at um, you know that temperature, and then you can read what the actual hydrometer is reading, and that'll, then you can calibrate on your chart. And so that's nice. The Murphy cups is like that, except the actual thermometer there, it's a thermometer, but they've removed the kind of temperature range, the chart that's on there, and they've put a new one in that is showing the bricks. And so it's more telling you that when the temperature is at, it's pointing at the line and if they should line up. So your hydrometer should line up with the bricks that it's showing on that temperature gauge, which is really not showing you actual temperature. It's showing you kind of the bricks at that level. And so they should line up with each other. They're kind of a quick and easy once you understand how to use them, but they're kind of confusing. And so I'm probably not doing a great job, unfortunately, at explaining it. But it is an option. Another option that's out there is a hydrotherm, which has kind of a mercury-like thermometer on the inside of the glass tube, and so they kind of sort of works like the Murphy cup, where they kind of need to line up together. I don't see those used all that often, but it is an option that you may come across. The Murphy cup, you do want to make sure that that thermometer is calibrated. I was doing a workshop a few weeks ago, and we had an exercise with a Murphy cup, and they weren't lining up, but even though the maple syrup was like perfectly 66.9 degrees, and it was actually 60 degrees. We were in a sugar house. It was heated, but not all that warm. And so it was perfectly 60-degree syrup. And the hydrometer was floating right at the cold test line. It was perfect, but the Murphy cup thermometer piece was showing us that it was off. And so it turns out that Murphy cup was not calibrated correctly. So that's something to check out and pay attention with as well. So there's things that some of these tools can be great, but they can definitely impact and throw things off. One thing I want to mention about the hydrometer is that our hot test line is 209 degrees, and at 209, even though we're finishing syrup at more like 219 degrees, but this is kind of based on testing and finding that when you actually draw off the maple syrup and put it into that smaller cup, that there's going to be some cooling that's going to happen, and that's typically going to cool down to 209 degrees. So if you're drawing off hot finished maple syrup, it's going to be right around that, and put in your hydrometer cup, it's typically right around 209. And so you generally don't need to measure the temperature right then. But if syrup has cooled off for any length of time, and it can happen quickly, even within less than a minute, it's important. It's good to measure the temperature that's there. I'm going to skip over that one. All right, so moving on to some other things to think about. So filtering and clarity of maple syrup is, another important concept, and that I think this one's a little bit more given, in that we want to make sure we have a clean syrup for our consumers. That it's a requirement to make sure you filter your maple syrup, but we want to make sure that it has a nice, clean, gourmet-looking product. But there are no foreign objects. You don't want any dead flies or anything like that. And so I was actually judging some maple syrup at a fair this summer, and looking at one of the samples. I always, it's one of the aspects, is looking at the clarity, how clear is it, and making sure there's no foreign objects. And it turns out there was a hair in the maple syrup. So that was pretty gross. I didn't taste that maple syrup for that sample. That disqualified that for the hair that was in there. So want to make sure nothing like that is getting into your bottles of maple syrup. Make sure your bottles are clean. They're not, you're not getting dust wherever you're storing them. If they're in a sugar house all summer where it's dusty, or an attic or something like that, anywhere that make sure you keep them covered and where mice can't get in there, but any dust or anything like that, bugs, spiders. So that definitely is not something that the consumer is not going to be really happy and is probably not going to come buy syrup again from you if they found a dead bug or hair or mouse droppings or anything like that. Um, The Another thing to think about is when you're filtering is making sure that your filters are clean. Whether you're using filter papers and like a filter press or using some kind of felt um, gravity filters or any other type of filters that are out there, is making sure that you're storing those filters in a dry area, not an area that has a lot of humidity where those can get kind of musty or moldy over the off season. Um, you don't want them in a perfectly airtight container where they can get kind of musty too. You want them to be able to breathe. But again, making sure there's no rodents or bugs getting in there as well. Don't store mothballs in with them. That's going to give any off flavors. Don't wash them with detergents. The best is to just boil in clean, pure water and then air dry them, hang them up to dry in the air. Don't put them away damp where it's going to get musty. Don't put them in your washer machine. That's going to get detergents, even if you're not using any soaps, but if there's any residual soaps or anything like that, that could get into there, that's going to get into that maple syrup. The worst thing you want to do is to do all that work making maple syrup and then you ruin it by getting some kind of off flavor into it when you go to filter it, that kind of, almost that last step. Um, Going back to my Q&A, Neil said we have always used hydrotherms too all the time. What's up with not delving into them? I guess the reason I'm not going into them too far is that I don't personally see them used much. Maybe they are used a little bit more in Nova Scotia than I realize. They are you're going to use them much like you use a hydrometer. It's just they're a little helpful that they have the thermometer kind of built into them. So you're just trying to line those two up. So they can be a great tool to use if you're familiar with them. And if you have more questions about hydrotherms, I can certainly happy to answer those offline at some point. We want to avoid any allergens. This is important aspect that the worst thing that can happen in the maple industry is if somebody were to get sick or was on the headlines that, somebody died or got sick from consuming maple syrup from some kind of food allergen poisoning or something like that. You see outbreaks of lettuce or other different meats or something that, you see recalls in those foods from grocery stores because people are getting salmonella poisoning or something like that. I mean, we're fortunate in that maple syrup was a little bit more lower risk as far as food safety standpoint, but there's things that we don't want to get people sick at all. We want to make sure we're representing the maple industry. And even if you're a small producer only making 10 gallons of syrup, you're still representing the industry out there, even if you're giving away your maple syrup. And so it's important to avoid any allergens that could get into our sap or syrup. And so it's don't cook any food in your sap while it's boiling. I don't think this happens as much, but I'm sure there's still people out there doing it. It's maybe hard to tell in this picture on the right here, but this is actually some eggs that are boiling in somebody's maple sap in their evaporator. And this kind of whitish stuff on the left here is actually one of the eggs opened up and started oozing out into that maple sap. So that's pretty gross. You don't want that into our products, right? I hear people steaming clams or something in the back of their evaporator or boiling hot dogs and different things. So keep those separate. If you want to do that, put them in a pot and put that on your stovetop or a little burner. If you're only making that maple syrup and consuming it yourself, and then maybe you're do what you want to do there. But if you're selling it, especially, but even if you're giving it away, don't do any of that stuff. I guess it's just what I'll say that. And also be cautious with any other potential allergens. Like if you're for defoamers, don't use any nut oils, peanut oils, or anything like that. Soybean oil as a defoamer. A lot of people have allergens to that. So make sure you keep those in mind also. All right, and so another aspect that's important to think about when we're producing a quality maple syrup is actually grading our maple syrup. And I know this is a topic that hasn't really been approached in Nova Scotia, and that most people in Nova Scotia are not actually grading their maple syrup. But from my reading of the regulations and standards in all of Canada, and talking with maple producers who are associated with Canadian maple syrup at the governmental level, in that all maple syrup is required to be graded to one of 4 grade standards, unless the producer does that themselves, unless, as long as it's not being sold outside of the province. If it's being sold outside the province, then I believe CFIA is involved with that. And if it's 100 milliliters or smaller, it does not have to be graded. So little nip bottles and things like that are used for wedding favors or whatever, souvenirs, don't have to be graded, mostly because they're small bottles and it's hard to put all that information on there. But anything larger does need to be graded. And the important reason why we grade our maple syrup, put into these grade categories, is because it helps kind of differentiate these different flavors of maple syrup into their own unique categories. And so this provides consistency for consumers. And so when we look at the grades of maple syrup that are out there, there are 4 grades of maple syrup. So any table grade maple syrup that's being sold retail to consumers is all grade A, and then it's split into 4 separate categories. And these grades they're graded based on the amount of light transmittance that goes through them. So it's all based on color, although the new grade system that was incorporated like around 10 years ago or more now, which is standardized between the US and Canada and all states and provinces that are looking at the actual, that adds in both the color aspect, but also adds a flavor descriptor to there. The downside of the grade system, and it can be tough and it is hard to educate consumers on it a little bit, but it's also nice in that, if you had a consumer who buys golden maple syrup and then goes and buys maple syrup from either same producer or a different consumer and gets maple syrup, and that time it's more of a very dark maple syrup, they're probably going to be disappointed, or it's not what they're expecting. And so it's good to provide them what that maple or that consumer wants, the preference that they have to it. And so there's different uses for different types of grades. And so it is confusing, though, in that it's graded just based on color, where flavor doesn't come into it, although typically darker in color, the stronger the flavor of maple syrup. So our lightest golden color with a delicate taste has a light transmittance of 75% or more. Amber color, rich taste, 75% light transmittance goes through it to 50%. Dark robust, 50 to 25. And then anything below 25% light transmittance is very dark color with a strong taste. And so the way we classify and actually grade our maple syrup, there's a few different methods out there. The 2 kind of most common, there's these temporary grading kits. These have the standardized colors that you get 3 of them. And then there's always an empty one. And so this empty one is set that you can fill that with your sample, and then you put it inside this box and you're comparing it to the 3 that you have. These 3 colors are kind of the cutoff points. The lightest one is 75% light transmittance. So anything that's lighter than the lightest, so if your syrup is lighter than this lightest one, the 75%, then you'd be a golden syrup. If it's darker than this one, but it was a little bit lighter than this one right here, would be a 50%. So that's more our amber. It's a 50% light transmittance. So if you're between 75 and 50, you would be an amber maple syrup. If you're darker than our 50% or amber, but lighter than this 25%, which is our dark, then you're a dark maple syrup. And if you're darker, there's not a fourth one. There's not a very dark, because again, anything darker than this one is the very dark syrup. So these don't necessarily represent actual grade of syrup. This is more of those cutoff points of 75, 50, 25% light transmittance. The thing to note though with these is that these can actually fade in color over time, especially if they're in sun, but even if you're keeping them in the dark, that over time these will lighten. So they're called temporary grade kits because you usually should be replacing them every 2 or 3 years because they can lighten. Another option that a lot of producers are using, it's made by Hand Instruments. It's the color checker, this little purple egg thing. Comes with these little glass tubes. You pour a little sample in there. It comes with a clear, one that has a clear solution into it. You put that in to calibrate it, so that should read 100% light transmittance. And then you take the one with your sample and you put that in, you hit the button, and that measures the actual percentage of light transmittance, and it'll tell you. So in this particular case here, that is showing 63% light transmittance. If we look back between 50 and 75, you're on the amber range for maple syrup. And then you can buy these different grade stickers from maple supply companies to put on, or put on your own label. The one thing to take note is that it's well known that maple syrup will actually darken in containers over time, especially plastic containers, within a month. That sometimes you can change a whole grade, a color grade, especially if you had a syrup that was, say, 55%, which would be technically an amber syrup. It's over 50, less than 75, but that can darken in time. And within a month or so, or a couple months, because oxygen can get into those plastic containers, and it may drop down into, say, 48, 45, which would put it into that dark syrup. So it will darken. So it's also good to taste maple syrup and grade a little bit based on taste as well, within those categories. Any questions on grading maple syrup? Just kind of pause for a second for that. I do see there's a question from Allison asking recommendations for defoamer. We are a small family scale. The most effective defoamer is if you can buy a commercial defoamer from a maple supply company. Those are the most effective, either a liquid form or you can get powdered form as well. It doesn't take much. You don't want to use a lot of defoamer. The less, the better. You don't want your maple syrup to taste like defoamer if you get too much in there. That can actually, we'll talk about that in a little bit with some off flavors. If you are going to use oils, some different cooking oils can be effective. It requires more of them. Saffron oil, sapphire oil seems to be used a lot by organic producers, but even some canola oils can work okay. They're not quite as effective, but they can work. But if you can pick up a little bottle of the kind of commercial defoamer, that's going to be the most effective. In the off season, I would recommend putting it in your freezer to store it so it doesn't get rancid on you. That can be something that can change the flavor of your maple syrup, is your defoamer. If it's old and it's been sitting around, especially being warm, it can get rancid and add some off flavors into your syrup. All right, feel free to put more questions in the chat. So last few little things, then we'll get into flavor. Bottling or canning, really important as well, to make sure you hot pack into clean food grade containers. Don't use, recycle. I'm big about reusing and recycling, but you want to make sure any containers that you use are not going to give any off flavors into that finished maple syrup. So something that had some kind of food in it before that was really strong, you want to be careful with. Obviously, don't use any oil cans or pesticide containers that aren't food grade, but even things that may have had mayo in it or oils that could still be in that container that get into your maple syrup. And even I've had some things with some glass containers that didn't get cleaned very well. Typically glass is better. You can clean it more. But I've had like some pasta sauces and some fruit juices that gave some flavors into the finished maple syrup. And so again, goes back to you do all that work, and the worst thing you want to do is taint the flavor of your maple syrup because the container had some kind of off flavor. So smell them. If you can smell peaches or pickles still in that pickle jar, don't put your maple syrup into it because the maple syrup is going to soak up those flavors and it's going to taste like that. So you don't want pickle tasting pancakes or whatever you're using your maple syrup on. But although it could be good in some things, maybe. When you're hot filling is really important, so make sure you're at least 180 degrees Fahrenheit on the minimum. That's our sterilization point for killing any type of molds or other pathogens that could be within that maple syrup. We don't want to go too high a temperature. If we get too high over 195, 200 degrees Fahrenheit, that's necessarily a bad thing, but you might start to get water evaporating. That might change your density of your syrup, but more importantly, you're going to start to get niter sugar sand that's going to start to precipitate out, minerals precipitate out of the syrup and settling, and so you won't have a nice clean product. Especially if you're bottling in glass, you'll get a little bit of sedimentation on the bottom or cloudy maple syrup if you get too hot. That's going to start to form again. So you don't want to bring it to a boil, but even getting below that at like 200 degrees, you'll start to see sugar sand forming. So you'll think like, oh, I got this really nice clean product, but then as it sits there over a couple weeks, you'll start to see sugar sand forming on the bottom. Also important, make sure you tip the jugs of maple syrup or bottles on their side for at least, 10 seconds or more, half a minute, to the hot syrup can get up around the neck and the cap of the bottle to sterilize the top as well, so that that's not cold and doesn't sterilize, and you have potential pathogens up there that could then form mold in your maple syrup. Also, if you're bottling in really small bottles like we have here on the left, these little nips, those are more prone to get mold forming because when you put that syrup in, if that glass is not really warm, it can cool down that syrup really quickly, faster than what that has time, because we need a little bit of time for that syrup to actually interact and kill any pathogens that might be there. So especially if your bottles are out in your barn or something like that where they're cold, you want to make sure they're at least up to room temperature, but even higher. Some people will sometimes put them in the oven or even a hot water bath to actually warm them up a little bit, those really small ones. Bigger bottles, there's enough volume of syrup that will heat up the glass. You still don't want any syrup, even a bit larger bottles, you don't want to be putting hot syrup into those cold bottles, but these small ones, even if they're room temperature, can sometimes be an issue. So keep that in mind. So Allison has a question on that. I didn't mention a Brix range for grading syrup, which I thought was interesting. I didn't realize it was color and taste only based system. So when it comes to grading syrup, the density that's a given. We have to have, if we think about regulations, it has to be the correct density of 66.0 to 68.9%. So that's definitely a given. It has to be filtered. And then the last piece, that the grading is, people, I guess, can define grading in different ways. What I was referring to in grade is more based on the actual 4 classifications of, which is looking at really just the color, although taste is associated with that color typically. So the golden, amber, dark, very dark. So those 4 grade A's. So the density is density is part of that. It is, if you look at the standards, density is 66.0 to 68.9%. It has to be within there. It has to be filtered, and then to one of those 4 grade classes. If it doesn't meet those standards or doesn't have the correct flavors, then it gets into off flavors and should not be sold retail that's processing maple syrup, which we're going to get over in just a little bit. So speaking of that, taste. Always taste your maple syrup. This is really important to taste your syrup, and it's also really important to taste other people's syrup. I would highly recommend, if you have neighbors around you or friends, or get together as a group and actually share maple syrup. What we find in the industry is that a lot of times people are so used to the maple syrup that they make that they don't know maybe what other maple syrup can sometimes taste like from other producers, or maybe they're not doing something right. And this is what they think maple syrup should taste like, where it turns out they're not doing something correct. And they have some kind of off flavor, but that's just what they're used to. And sometimes friends and family are not willing to tell you that something tastes off, unfortunately. But I mean, I've judged maple syrup at contests, and it's amazing the amount of syrup that a bad syrup that I have tasted in a contest where you would think people are submitting their best product that they made that season, and it's surprising that you taste it and it's like, this is gross, or this has this off flavor in it. And did they not could they not tell that this had the soft flavor in there? And so it's like, are they even sampling their maple syrup? So make sure you are sampling every batch of maple syrup. Every time you bottle, if you're barreling your syrup before you bottle, before you go to bottle it, things can change between production and bottling. That's the first thing I do when I open a barrel of syrup is I taste that syrup before I do anything with it, make sure it still tastes okay. Um, and so that's really important. Also, when you're sampling syrup, besides just tasting other people's syrup and getting other people to sample your syrup and give you an honest feedback, but try to sample it at different temperatures. Don't just always sample it straight off the evaporator. It's going to taste much different if it's at room temperature. So if we're making maple syrup, especially late in the season where you're starting to maybe get some off flavors, I always like to take a sample, take it outside and let it cool down. And even step outside, especially if you're around that evaporator and there's a lot of steam, a lot of times you'll get off flavors in the steam smell of it cooking before you will in the actual flavor of the maple syrup. And so get out of your sugar house, get into some fresh air or a different spot, and sample it. Make sure you're not tired and worn out from making it all night. Sample it the next day, make sure it still tastes okay. That's really important as well. So when you're sampling, smell it first. That's also really important. Smell it, take some of the off flavors you can get just in the aroma. So what does it smell like? You don't want anybody to open a bottle of maple syrup and it has this nasty smell. So make sure it smells okay. Take a small sip, kind of let it kind of move around in your mouth, get to feel the mouth feel, the density of it. And you have different taste receptors on different parts of your tongue and mouth. And so you want to make sure you get syrup to kind of coat all those different taste receptors to pick up all the different unique flavors. So then it kind of evaluate what is that mouth feel, evaluate that flavor. How does that taste? What flavor characteristics are you actually getting? Um, and this takes practice. If you're making only sampling your syrup and it tastes, much the same all the time, it's going to be hard to pick up some of those differences until you really sample other syrups. And it's good. I like to always take one sample and then, pause for a little bit, think about it, and then take another sample, two or three samples, and just make sure that you're really getting a feel for that, or especially if you had some other taste in your mouth. That first one, you may not pick up on all the flavors as much. Center Acer created this flavor wheel for maple flavors. So they have all these different things. They have different types of flavors that may or may not be in maple syrup. Some are good, some are bad. If you get more foreign things, but things on vanilla, the confectionery, maple flavor, which I still haven't had. I mean, you hear people say maple flavor, but it's hard to define what is that actual true maple flavor, right? So if it's the wheel of maple flavor and then there's maple flavor within that, I think is a little odd in my opinion. But there is that what people do classify as maple flavor. So sample your maple syrup. And so hopefully we're making good maple syrup, but it's also important to sample that and try to detect any off flavors that might be in your maple syrup. And this takes practice to know what truly those off flavors actually are. You kind of need to have a sample of that and somebody tell you this is sour maple, sour or fermented, so you can kind of associate in your mind what that flavor actually is. And so it takes time, it takes practice to be able to detect and pick up some of these off flavors that can be in maple syrup. And so a little embarrassing picture, but this is a picture of myself from actually judging syrup at the North American Maple Syrup Conference this past fall. That was held in Massachusetts that year. That doesn't matter. Its sample wasn't from Massachusetts anyways, but This was a sample that I took, and we smelled it, and it just smelled awful. The density looked weird. It was like black in color. But I decided to be brave and sample it anyways because I think it's interesting to taste different types of maple syrup, even off ones, that try to figure out what's off or what's wrong with that. Um, and also, again, it goes back to more practice, tasting different ones. You start to build more of a profile. And so I was Mark Giselhart, that I was from University of Vermont, that I was judging with. He snapped this picture because he knew it was going to be pretty bad of me tasting that, and it was probably the grossest maple syrup I'd ever tasted. But and again, this goes back to, this was in a contest. Like, there was a lot of nasty maple syrup we tasted that day that were submitted in a contest. So it's surprising. So tasting your maple syrup, making sure it's in the correct density. There's a lot of syrup in contests that um, are disqualified from a contest because maybe the density is not correct. So we're always measuring the density. That's we get that off, or it's not in the correct grade, especially dark syrup oftentimes is not in the correct grade. Um, Light syrups are oftentimes off in density, or oftentimes too thin sometimes, but you also get stuff that's too thick. I know it's harder on smaller production size to do that, but we do get a variation. And then I mentioned, the hair, you get things like that. And then off flavors, especially in the dark or very dark syrup, you start to get off flavors, because those are usually your late season syrups. That's where you're going to get more off syrups forming. So just want to go kind of a rundown of some different off flavors to kind of finish off tonight, to kind of think about, and maybe you can start to pick these up in some samples that you might make this coming season. Hopefully you won't. Hopefully everybody's making great tasting syrup, but things to kind of look for and take note of. One is the scorch flavor. This is a burnt flavor. This is typically later in the season. If you get a lot of fructose in there, you can go beyond caramelization, and you can get this really kind of scorched, this kind of burnt flavor. Can be like a dark chocolate. It's not always bad. A little bit of scorch can actually have more of this chocolatey flavor, dark, complex flavor. That's not bad overall, but you can also get scorch where it's really burnt tasting, kind of acidic tasting. This sample that in my face there in the picture was one of the things that was wrong among many, but it was really, really heavy scorched syrup. And so that is one aspect. So you'll start to pick that up. I've even had maple sugar made. I was judging in a contest, the confections as well, and there was sugar, and it had a scorch flavor. So the syrup was probably fine, and the actual sugar that was made from it, they got this syrup too hot or too quick, and the syrup, as they were cooking it down into for sugar production, actually scorched and got a scorch flavor into it. Um, Defoamer can happen if you get way too much defoamer. This is more of an issue for end of the season, or maybe really early in the season, but typically end of the season when it's hard to manage foam and you got to use more and more defoamer. Or if you're an organic producer, the organic defoamers usually aren't as effective. And so you're using way too much of it, and it leaves an off flavor in there. It's a little bit harder to pick up in the flavor. It can be kind of a little musty or a little rancid flavor, but in the after you've sampled it, you'll get kind of a waxy feel in your mouth, that kind of leaves this kind of like you almost chewed on some candle wax, and you have that in your mouth. So that's not the greatest overall. And so defoamer, metallic. I've had this before, kind of tastes like tin can, metally, hurt your teeth a little bit sometimes. So metallic, that can happen. This is usually maybe if you depending on the container that you're storing it, that can happen. Sometimes even without it, can just sometimes happen for whatever reason. But usually it's the container that it was stored in. Um, fermented, this is usually when syrup is fermented. So if you didn't cook it to a high enough density, and the actual syrup fermented, or maybe more the concentrate, and then you boiled it, and it has like kind of a yeasty, but kind of alcohol taste. Or I sampled some syrup recently, for a grading workshop we were doing, and that stuff, it was a fermented, but to me it tasted like a really cheap beer that was left out in the hot sun for 3 days, and so it was flat and just nasty, kind of that warm beer alcohol taste. It was pretty gross. It was really bad. So fermented can happen though. Sour sap, this is a little bit different. So sour syrup, this is usually more from the sap being sour, so being too warm. This sap, and I know a lot, and for me, we were making it at the very end of the syrup. We made, or end of the season, we made some commercial season that was commercial processing syrup at the end from the sap being just way too warm. We got close to 80 degrees Fahrenheit. And so that made in the air temperature, so that sap went sour, so the sap fermented way too much and made sour tasting syrup. Sometimes this can be not the worst. It can be, if you get just some sourness, it's kind of a fruity citrus sour flavor. It's not bad. It's almost kind of raspberry like fruitiness in the syrup that isn't awful, but it shouldn't be in there. That's not how maple syrup should be. So for your own personal use can be used that way, but it should not be sold for maple syrup, table grade at least. You can sometimes get detergent flavors, kind of chemical soapy taste. So if you're, that can come in filters that, if you wash in any detergents, or anything in your pans, if you use some kind of pan cleaners, soaps, detergents, acids that didn't get rinsed out fully, that can happen as well. Metabolism is a harder one to kind of define, and it's not the worst flavor always that can happen. And why it forms doesn't really, we're not really sure, but kind of has sort of a cardboardy, earthy, but sometimes can be a little bit chocolatey. So again, it's not the worst tasting flavor, but also not great. Buddy, so that's that end of the season when the buds are swelling in the trees. But as I mentioned, we don't know if it's actually because the trees are swelling or just other things that are happening, the different amino acids and sulfurs and things that are forming there. And so the range of buddy maple syrup flavor can really vary a lot. And a lot of times when you get into that buddy maple syrup, the end of the season, there's a lot of things going on at once. The sap is also sour because it's warm and it's buddy. So it's got a lot of different flavors. Some really subtle early buddy has more chocolatey kind of Tootsie Roll flavor, so really not all that bad, or kind of a citrusy orange flavor sometimes, but a really heavy buddy has this kind of lingering aftertaste that's just kind of off-putting in your mouth. That's not that great. So it can really vary. I know I have some people that say buddy syrup, like what we would maybe I'd classify as buddy syrup, really isn't buddy. That's just kind of late season syrup. It's not till you get that really heavy, strong, lingering aftertaste. Musty syrup, this can happen especially in late season, kind of has almost like a moldy, dusty, another lingering kind of finish that off just putting flavor in your mouth. That kind of mustiness, just kind of dirty, tastes like a wet basement or something like that. And then the last one I put up here is what I call late season funk. Um, and this is really just a combination of a lot of different things that are going on at the end of the season. Of it's sap's really warm, it's gone sour, there's buddiness, there's mustiness to it. And sometimes this makes your stomach kind of queasy, kind of doesn't sit really well in your stomach. And even if you're boiling around this, it makes your stomach and even that buddy stuff, it makes sure actually that steam of the taste of that steam and breathing that in makes your stomach kind of feel a little queasy as well. So that's not really a technical term, but I just call it the late season funk. So again, a lot of these stuff can all happen at once at the end of the season. So I'll finish up there and turn over questions, but I just want to finish with this quote that I like, that was actually an advertisement from a large maple syrup operation that was in place in the late 1800s, actually near where I'm located in northern New York, and that nature is the greatest chemist and we can do no more than retain the flavor created in the laboratory of the woods. And so just remember that, maple trees provide us this delicious maple sap, and when we cook that down, gives us this great maple syrup. But there's a lot of things that we can do that mess that up, whether it's the way we store that sap, how we process it, filtering, cooking eggs in there when we shouldn't be, or stuff like that. And so, but we want to make sure we're creating this quality product because we're creating this gourmet product for the industry, and we're all representing the maple industry. So it's important that we put out a good quality product. And even though it's coming from nature, there are some off flavors as we get later in the season, especially. So not all maple syrup is grade A maple syrup that should be sold retail. It's okay if you make off flavored syrup. I make off flavored syrup occasionally, but just make sure you're not putting it into retail bottles. So feel free to jump in with more questions. Put them in the chat or raise your hand, and Caitlin can unmute you. I see one from Charlie asking, "What's my thoughts on using an RO and the taste?" And so, great question on how RO is impacting flavor. Get that question quite a bit. There has been research done at that on that from the University of Vermont that found that there was not and they did, to truly do this, you need to make sure you're taking sap from the same batch, because remember, the chemistry of that sap can vary day to day. So taking the same batch of sap, separating it into two tanks, using the same type of evaporator, because it can change quite a bit from the type of evaporator you have, can change the flavor. And so they did that where they took half the sap, ran through an RO, took the other sap, ran it on two side-by-side identical evaporators, and found that for the most part, and then they took that finished syrup and did a blind taste test, where there's 3 samples of maple syrup. One where so you've got one cooked with the using the RO sap, one not using the RO sap, and then randomly there's one of the other. So there's really 2 of one sample and 1 of the other, and that third one is kind of mixed around. And so it's, can you detect a difference? And so if you say yes, but if there's only 2 samples, but if you have 3 and you're saying that there's a difference between the 2 samples that are actually the same, then you're not actually detecting a difference, because our mind plays a lot of tricks on flavor and taste as well. And so from doing this blind taste testing, they found that there really wasn't a detectable difference in flavor in the maple syrup, until they got to really high concentrations of, with an RO, of you going like above 30%, I think, like that occasionally there was a small detection, not that it was bad, but maybe a small detection in taste at the end of the season. But overall, even looking at different concentrations of taking it to 4%, 8%, 12%, that there wasn't a detectable taste in that maple syrup between the two. There was changes in flavor that typically, on the most part, there was RO'd sap in a syrup made lighter syrup, except for some reason, we don't really know why, but sap that was concentrated to like 8%, if I remember right, for some reason was darker than the non-RO'd sap, but stuff lighter than that, stuff concentrated to 12%, 16%, made lighter, a little bit lighter than the non-RO'd. So not entirely sure what was going on there, but what really, when it comes down to, we're looking at our evaporator. And again, if you're cooking on side by side, if you're cooking in a big pot or a buffet pan over a wood fire or a propane burner, you're going to be different tastes in syrup without an RO than what you are with somebody with an RO and a big, 4x14 oil fired evaporator or something like that. But if you're looking at, traditional maple syrup evaporator, most of your flavor is happening in your front pans. And so when your sap is coming into your front pans on your evaporator, it's going to be the same sugar concentration whether it was RO'd or not. So your RO, if you don't RO, it's going to spend more time in the back pan and the flue pan. If you use an RO, it's going to spend less time back there. And so in most of your flavor, most of that Maillard reaction and caramelization are happening at those high temperatures, which are happening really more up in your front pans, your finishing pans on your evaporator. So it doesn't matter quite as much using that RO or not, because it's still all getting that happening mostly more in the front of the pans. But I mean, there are variations, but and the way it's cooked and all of that that will change flavor overall. If you're using a steam evaporator versus an electric evaporator or wood-fired evaporator, oil-fired evaporator, there can be some subtle differences overall. So good question, Charlie. I know it's a long answer. Mitch asked, can you touch more on the phenols found in syrup? What would be comparable foods with similar antioxidants? Um, there's the IMSI, the International Maple Syrup Institute, has they made some charts a number of years back that shows the amount of antioxidants in maple syrup and compares that to like kale and carrots and apples and stuff like that. I can share that with folks if anybody wants to reach out to. If you send me an email, which is on the screen right there, I can share some of that stuff with you. There's also researcher at University of Rhode Island who's done some stuff for the maple industry, and for actually Quebec has had him do some projects looking at some of the phenols and the antioxidants that are in there. It's not going to be as high of antioxidants that you get in like blueberries or pomegranates and um, elderberries and things like that. Those are going to be much better for your antioxidants, but maple sap and syrup does have those phenols, and some of those are actually unique to maple syrup. There's one that this researcher from University of Rhode Island found that I think because the research funding came from Quebec for that, so it's named Quebecol. It's this unique polyphenol that was found in maple syrup that hasn't been found in other products that are out there. So I can share any of that stuff if anybody is interested. Question from Colin: would you suggest adding oxygen to bulk sap tanks or concentrate tanks that have been sitting for a while before processing? If you're holding it for too long, hopefully you're keeping it chilled. It can help though if it is sitting for a while and you're worried that it depends on how long it's sitting and how warm it is. It can be helpful doing any kind of splashing because the RO can actually strip oxygen out of sap. But I wouldn't let concentrate sit for too long unless you're keeping it cold in some way. So if you're using a chilled bulk tank, which is fine. We're finding that if you can store chilled concentrate, if you can keep it cold right around the freezing point, which can go even lower because of all the high sugar. If you keep it just from freezing, that you can store concentrated maple sap for quite a while without spoiling. And I wouldn't worry about adding oxygen at that point. Some of it's going to depend on if you want to make darker syrup. If you think you're making a lot of light syrup and you want to make a little bit darker syrup, then adding some oxygen into there could be good. The biggest thing I would be is just don't store that concentrate for too long unless you're keeping it cold. We're going to be hopefully doing some research over the next couple of years on storing concentrate cold, and doing some work on finding or making your own kind of sap chilling devices and ways to keep sap or either raw sap or concentrated sap cooler, so you can kind of work around your schedule instead of boiling around the maple schedule necessarily. So give you a little bit of break and keep that cold. So we'll be looking at some quality and stuff, but the oxygen aspect depends on if you want to make it darker or not. Trish asked, do you think the minerals, ground soils, and organic matter in different geographical locations contribute to different maple flavors as well? I think they do on a really, really subtle level. It's probably hard to pick that out. I think because flavor can change so much from farm to farm based on processing levels, and syrup just changes so much day to day, even within a farm, that it's hard to say that, oh, this is maple syrup from um, this part of Nova Scotia, or this is from Ontario, this is from New York, because there's so many other variables. But I do think that those minerals and their soils and everything that's there, that terroir aspect, does contribute to the flavor of maple syrup. So great question. Charlie put that we keeps a UV light in our tank and it keeps sap clean. So that's a great point to bring up, that there's been some mixed results on using UV. So it sounds like you have yours submerged right into the sap. Is that right, Charlie? Or is it hanging above the tank or something like that? Or does the sap actually travel through it? A lot of the work has been more around actually passing sap through like a UV light, which is sometimes people have that for their well water in their home to kill pathogens. And the research on that's a little mixed. It can help, especially the biggest things we find is if you are passing sap through that has a lot of larger microbes, pathogens in there, and it's passing through. Oftentimes we're passing sap through so quickly that the UV light's not able to penetrate all the way through the sap or all the way through the center of those microbial clumps. And so it's not always effective. It can do some things, but not 100%. It's best if you're doing that to filter it and then pass it through UV so that you can remove the larger pieces and try to move it through slow. Um, so Charlie says the light is in a glass canister in the tank. So I've not tried it that way. I don't know if anybody's done that for research, but I'm glad to hear that that's working well for you. That is it can potentially be an option. The way we've had it set up is more passing it through, and I'm not totally convinced it worked in that way. Where I think it was helpful, where I have used it, is I have one that was coming out of the concentrate coming out of my RO. So when it came out of the RO, the concentrate would pass through before it went into my concentrate tank. So if I wanted to hold that sap, that concentrate sap for a few hours or more, or even sometimes if the weather was cold, I would hold that concentrate overnight without chilling it, but my sugar house would stay cold and I could keep that concentrate in there. I mean, I concentrated, I had sap flow Friday, Saturday last week. I concentrated on Saturday, and kept and actually didn't boil that concentrate till Monday because we got cold Saturday night and it stayed cold and the quality was still there. But coming out of an RO, it's going to be it's going to be a little bit more filtered because you're going through your pre-filter on your RO and you're also passing it through a little bit slower on the concentrate side. And so that's a great opportunity if you want to do the pass through for the UV, but that's interesting to hear put in your tank. And I'm sure it probably does something. It may not do everything. You may not want to store that at 50 degrees for a week, but I'm sure it is helping to some extent. Any other comments or questions from anybody? All right. Well, I hope there was maybe some helpful tips for folks, things to think about as you're getting into this coming maple season, which I'm sure may have started a little bit already for some folks and will definitely be getting going within the next few weeks, I'm sure. So.